Hello students, welcome back to my channel. In today's session, we will be learning the algorithm to generate pseudo-random numbers. Now, first let us understand what is a pseudo-random numbers. When we talk about random numbers, it is just generating the numbers randomly, just like the name says. What is the application of this random numbers? So these random numbers mainly used in your cryptography, where you have to generate a random pin every time. Okay, and these pins cannot be of same pattern or a same number. It has to be random, mainly because nobody should be able to hack it. So you would have seen your OTP. OTP numbers are gets generated randomly. Similarly, in many industries also random numbers are used. Okay, so that is the purpose of random numbers. So whenever we talk about random numbers, there are true random numbers and pseudo-random numbers. So true random numbers is which we generate in real world, and also which gets generated random numbers. There is no repetitions, etc. Now here we will be talking about the pseudo-random numbers, mainly because when we will learn the algorithm, you will understand that after a certain steps, the values get repeated, and then that is the drawback. So that is the reason we will say that it is a pseudo-random number. Okay, so let us go ahead and see what is the problem statement, and we will also see how can we generate random numbers. So the problem statement tells us that use a linear congruential method to generate a uniform set of pseudo-random numbers. So that is a method usually which is used in order to generate a random number. Now you might also would have seen that in C we have a function itself called as a rand. This is to in order to generate the random numbers. Now our purpose is to create our own methodology in order to generate. This is the shortcut method. Okay, this is the built-in function which you can use in order to generate one. But today we are trying to generate our own random number generating algorithm. Okay, so let us see what is linear congruential generator is, which helps us to generate the random numbers. So it says that a sequence of pseudo-random numbers x1, x2, etc. between 0 and m minus 1, where m is the upper limit we are giving, is generated using this particular expression. So this is your linear congruential generator generating expression, where it says that xn plus 1, which is nothing but the next random number is nothing but a into x to the power n, where x to the power n is the current value what got generated. So xn plus 1 is nothing but the number after n. So we will use the previous number, we'll multiply it with the value a, and then we will add a constant, and then we are going to perform modular operation with m, where m is nothing but the upper limit of the number which I want to generate. For example, if I want to generate the number between 0 to 99, then m value becomes 99. Hence, I'm performing the modular operation here. Okay, I hope it is clear. So the next value of a random number is created by multiplying a and the current value of x, then added with the constant, and this whole thing is divided by m, and the remainder whatever we get is the random number. Okay, and always remember here m value is always greater than 0. A value should be between m and 0, and b value also should be 0 and m. And then here your x naught is nothing but we call it as a seed. X naught is called as a seed value, or it is the initial value of the random number with which we are going to start the value of start generating the random numbers, because we always need something to start with. That is why it is called as a seed value. Okay, now let us see the algorithm, and then we will simultaneously we will do one example as well. So it is a very simple algorithm. So set parameter values for multiplier a, b, modulus m, and initial value of x naught. Okay, so here this is not p, here you can write it as c. Okay, so generate successive members of linear congruential sequence using this particular formula for all m greater than 0, and repeat steps for n numbers. So that's what we are going to do. So let us take an example. Okay, So we will take one example where we are generating the random number for, let us take the seed value, that is x0 as 27. Let us take a value as 17. Let us take c value as 43, that is our constant. And let us generate the number until 100, that is m value, let me take it as 100. All right, so now let us start. Initially, the first x1 I have to calculate. The x0 I already know, the next random number. So which means in the output, we already have 27. Okay, now x1 is, what is the formula? A into, so 17 into, and x0 is nothing but 27 plus the constant, which is 43 mod 100. Okay, now if you calculate all this, you will get 502 mod 100. Okay, which is nothing but 2, which means the next random number we are going to generate is 2. Let us see the x2. What is going to be next random number? Once again, 17 into, now I am going to take the previous value, which is nothing but 2. 17 into 2 plus 43. Rest all things remain same. Mod 100. Now this is nothing but 77 mod 100, which we already know that 77 mod 100 is nothing but 77. Hence the next random number is 77. Let us calculate x3. So 17 into 77 plus 43, 100. So this calculation will give us 1352 mod 100, which is nothing but 52. Hence, the next random number is 52. So you can see how the randomly numbers are getting generated. Let us calculate x4. So x4 is nothing but 17 into 52 plus 43 mod 100, which is nothing but 827 mod 100, which is 27. So as you can see now, we are getting the same value repeated. Now once again, if you calculate x5 for 17 into 27, etc., etc., it is going to be same as this, which will of course generate 2 and then repeat. So this is observed that if you're using a linear congruential method, after a certain set of random numbers, the same pattern gets generated once again. So that is the reason I said this is a pseudo-random numbers. Okay. So this can be overcome by taking a very high value of m. If you're taking a highest value like a huge value, for example, if I had to say 2 to the power 35 or something like that, if you take, only then up to certain level the values will not get repeated. Since we have taken a small value which is 100, things will get repeated very soon. But the concept here is to generate the random numbers. I hope this is clear. All right. So that's all in today's session, students. If there is any doubts, kindly message me in the comment section. So thank you for watching. Keep learning.